Welcome to the beginner's tutorial for the Mehta method. Proposed by Yash Mehta in 2020, it promises to be a new, top speed solving method for 3x3. Not only does Mehta sport a relatively low move count, it has high TPS potential as much as the solve is algorithmic. If you're just curious and want to try it out, this tutorial for the beginner version is for you. Experience with CFOP and RU is recommended. There are 6 main steps. First block, belt, orient edges, orient corners, solve corners, and finally solve edges. Here is the scramble so you can follow along. Step 1. First block. Build a 1x2x3 block on the bottom left of the cube. For this tutorial, we'll choose white as the bottom color. This step is done intuitively. The easy way is to solve 3 cross edges and insert the 2 remaining corners. However, the more efficient way is to do block building, just like the RU method. Form chunks of the block by matching up white pieces. For this scramble, I noticed this pair already formed, and that a D move also lines up this pair. The first pair I noticed can be placed next to this edge with U2, L2, forming a square. Then the other pair can go in with a B prime. This technique can be tricky, so if you need help with first block, check the description for RU first block tutorials. Step 2. Belt. Solve the edges in the middle layer of the cube to form a belt. Because the edges are not on top or bottom, they don't have yellow or white. Find one of these edges on the top, and align it with a centerpiece that matches its side color. Then move that centerpiece to the right with a wide U move and insert the edge with an R move. Repeat this process. Find an edge, move it and its matching center to the right, and insert the edge with an R move. And once you solve a few edges, you can't insert with R anymore without disrupting another solved edge. Instead, you can now insert edges like F-dual pairs. If the edge you want is stuck at the bottom or the wrong part of the belt, you can replace it with a random edge and continue as usual. Now the belt is solved. You don't need to align the belt with the first block. From now on, we will use algorithms for the rest of the solve. Check the description for a full alg sheet or pause the video right now. Step 3. Orient edges. An edge is oriented if it has white or yellow on the top or bottom. Focus on the oriented edges on the top and notice the pattern they make. There are 5 possible patterns. A quick note, yellow on the alg sheet represents either white or yellow on your cube. In this example, all edges on the top are not oriented. This is a dot case and I will do this algorithm. Now the cube reaches a state called EO ledge. Step 4. Orient corners. Like edges, a corner is oriented if it has white or yellow on the top or bottom. In the beginner method, we'll split this step into 2 parts. The first part is 601. Orient the bottom corners. Interestingly, you don't need to look at the bottom corners, just look at the top. If you see 2 adjacent oriented corners, move them to the left and do R2, U2, R2. If not, find 2 opposite unoriented corners in the top layer. You will always have one of 3 cases. Here, we see that these 2 corners are the slash case. Now the bottom corners are oriented. Let's move on to the second part, which is 6CO2. Orient the top corners. This step is identical to the second step of 2-look OLL, and you can use the same algs. For some cases, the alg sheet contains shorter algs which you can learn. Now your cube should have only white and yellow on top and bottom. Step 5. Permute the remaining 6 corners. Again, we'll split the step into 2 parts. The first part is 6CP1. Solve the bottom corner at the back. There are two white corners. Find the white corner that belongs at the back of the cube matching the bottom block. Do not match the belt. Make sure you match the bottom block. Solve it intuitively with R2 and U moves without breaking the belt. For example, when the corner is on top, move it to the left, do an R2, any U move to move it to the front right, and an R2. If the corner is on the bottom front, you can take it up with an R2, reposition it with a U, and then put it back down with an R2. The second part is 6CP2. Solve the remaining corners. Focus on the color patterns on the top layer. There are three types of patterns: headlights, opposites, and adjacents. If all top corners are yellow, you can use a PLL algorithm. Use JPerm where you see one pair of headlights and it's on the left. Use YPerm at any angle if there are no headlights. Otherwise, there will be one white corner on the top. Move it to the back left and you have one of these 6 cases. Step 6. Solve edges. If you have a white edge on the top, move it to the front, make sure the first block is at the back, and solve it with m'U2M. Then you're left with one of 4 edge PLLs. Align the layers, and you're done. Here's another example solved to see the Mehta method in action. Alright, the first step is first block. I'm going to build the first block on the white side of the cube. So we're going to look for some white pieces. I see this edge and this pair, and these two combine into a square with L2, F2. Then let's look for some other white pieces. So we have these two white pieces that can go together, but I also notice these two white pieces, and they can join really easily with a B prime. Then I can insert them to where they belong relative to this block with an RB prime. And this forms our first block. Step 2 is a belt. We're going to look for our belt edges which are non-white and non-yellow. So this is the first one I see. It's already attached to the center that matches its side color and they're both on the right. All I have to do is insert with an R2. And that solves this edge. Moving on, I see this edge, which belongs here. So I will line it up with the center that matches its side color, and then insert with an R2. And I'll move on again with another wide U. And I see, oh, these two edges actually solve together. That's pretty nice. Let's move on to the third step, which is orienting edges. I only look at the top, and I see this is a small L pattern, so I would do this algorithm. And this might be a little hard to finger trick, so watch my right ring finger. So you have to kind of push it, the F, like this. Alright, so that orients our edges, and now let's orient some corners. For 6C01, I'm going to first look for adjacent oriented corners, and I don't see any of them, so I will find two opposite misoriented corners. And this is a V case, so I will do this algorithm. And that orients these two corners. For 6CO2, I notice that this is the L pattern, so I will do this algorithm. Now we're going to solve the corners. And the first part is 6CP1, where I will locate the white corner that belongs to the back and solve it. So this is not the one, so this corner must be the one. It belongs here. I will do an R2, and then move this corner to where it belongs, which is here, and then R2 to move it back. So this is now solved. For 6CP2, I'm going to make sure that this white corner is at the back left, and look at the color patterns here. So this is a pair of opposites, and this is adjacents. So for this case, I will do this algorithm. And now all that's left is solving the remaining edges. I see this white edge, so I will insert it here with m prime u2 m. And that leaves us with an h-perm. What's next? There are 3 flavors of advanced Mehta that you can learn. The first is called Mehta 6CP. It's a continuation of beginner Mehta that combines many steps but uses more algorithms. The second is Mehta OS. Solve like a choose-your-own-adventure story. During the solve, choose whichever path is best for the cases you encounter. The third is called Mehta TDR. It's incredibly move efficient at 40 moves per solve and solves everything after EO ledge in just 2 steps. This method is made to break world records. I hope this tutorial was helpful. Thanks for watching.